Welcome. My name is Yushan, a PhD student from the University of Oslo, and the first institution of marine operations, NTNU, is the place I'm working as the research assistant. And my supervisor is Sisse Finken, she's there, come from the IT University of Copenhagen, and she was in the Linnan University in Sweden when we wrote this article half a year ago. A little bit background about the visualizing the actual Nightwalk for the maritime technology. Maritime technology is like this. It can be navigation. It also can be the farming at sea and shipping, subsea operation, and so on. And today's my topic is none of this. My topic is about the operation between the offshore vessel and the platform and the sea. And this picture is part of my field work that is happens at the North Sea between the Scotland and Stavanger. When this is the marine system, the operation system used for marine technology to control the vessel when they do the cooperation with the platforms. And this is the system they designed, especially for this area. Maybe I can use this one? No. Okay, fine. As you can see from the upper place, that is the control room. The control room, which is usually two or more operators sitting there to control the vessel. And the lower place, that is the engine room, and some things just to control the vessel, like the engine, the wind, and the waves, that to move the vessel, not for the navigation purpose, but to position the vessel nearby the platform. And this kind of the system exclude how the human beings to control the engine systems and the moving the vessel to the proper position. That means the human operators, they just simply interact with the buttons, like the press the button, but do not control the system. So this can be called automation. And now this kind of the system for more and more complex work, when people need to cooperate with the platform like this, it requires the people on the platform and the vessel to cooperate, not for the automation purpose, but for the cooperation purpose, how the people manipulate the system to make these big machines to work together. And this, sometimes, due to the high waves, sea waves, and wind and the sea, can cause some risk operation for human beings, and sometimes unsafe operations. When I mention unsafe operation, it not means the system has some failure. It's kind of people make some wrong decision to react the situation they face. So, like this. As you can see from this picture, the crew members on the deck, very small. They're even smaller than the container. So this work is kind of to moving the ship to the near even closer to the platform, and making some service to the platform, like loading the cargo and a container to the platform and taking some containers back. Sometimes they also need to give some fresh water to connect the path between the vessel and the platform. And you can say the waves there and some wind, but you cannot say the wind from the picture, but you can say the big waves. So this can cross the ship. Sometimes it's too dangerous to close to the platform, and sometimes there are some imbalance situation for the people who control the vessel. Hence, when we face the automation and cooperation, we need to think about how to bring human operators' cooperation work into the account, as well as how to integrate this kind of the social activity of the human beings' cooperation into the system design and for the automation purpose. So this leads to our research question, how to develop the method to scope the cooperative work in a system design for marine engineering field, and especially for marine operations for the cooperation purpose. And I used one concept, which is the awareness, and one theory, the actual Nightwalk theory. The awareness I used here is quite different with the most engineering design field when they discuss the awareness. That awareness for them is kind of the psychology model for the human beings to process the information in their model to understand their environment. And the awareness I used here is to analyze the ad hoc, the activities that unfold, which is unfold in the cooperation, which means the human beings is not to acquire information to understand the materials or the environment they are immersed in. They are kind of to use their professional skills in their familiar in work environment to react to the tasks and to make the cooperation between the co-workers and the machines and even bigger machines like the platforms. So I used the awareness to continuously establish, to analyze the interactions and activities that individual workers to complete their work, and put into some effort to analyze how this kind of work means cooperation task for the human beings work on the bridge, work on the deck, and work in the engine room, as well as the who works on the platform to make the work complete, like the cooperation between the vessel and the platform. I borrowed the ANT as the theory. The ANT here, the theory is different with the theorist who used the theory to describe what's the phenomenon happens there. I used the ANT here. It's kind of the two, or you can understand that it's a map. I want to visualize it for the maritime engineers. So the purpose is different. But there are some challenges for the awareness used in the design world, as well as the ANT. The awareness now in the design world, we use that observing and listening to what the activity is and to describe how the people aware their work and describe this kind of phenomenon or identify the problematic area to the designer. This concept used mostly in the design field, and for the engineers, when they talk about awareness, they understand awareness kind of situational awareness, how to make machine to react to some activities for human beings, not human beings who to interact with the machine. So it's different with the designers expected. So there's some, I cannot say that's a gap, there's some distance of understanding between the two communities. And for ANT, and you can say the system they design like this. This is for the position of vessel near to the platform, like that. It's for the individual person to interact with the machine. And this can be duplicated for all the operations for current system design for the marine technology. And when the people who work with the machines like this, to uploading some stuff to the platform, as well as the cooperating together to move the position, to move the ship to a proper position, or communicate with the platform like that picture. This requires a group of people to interact with a group of machines. The machines is integrated together. It's not just to simply position them together. So ANT can help to to outline what's the relations between these machines and the human operators and how they intervene together with their work practice. I will present a case and use this case to illustrate the approach we developed. This is the case I did almost 6 months, but not continuously, each time 10 days or sometimes less than 10 days at the Norwegian Sea and the North Sea, following the offshore vessel to observe and listen to how they work together with the machines of the human operators. The left side is the working place. You can say there's the two operators sit there, and they have some screens. The screens, they have the positioning, the DP positioning system, and they also have the navigation system, and they also have the radar system and the monitor system. So all these kind of systems are located together, like this, with respect to the human factors. They analyze it as the most human factor engineering. They studies like how to position the screens and how to position the vessel, but it's not taught the systems level. So this is the place they walk, and this is the two persons who walk together, the right side. And the case I most addressed in is the thematic positioning operation. As you can see from this picture, the right one, this man, he called himself first operator. His main duty is to position the vessel near to the platform, to a very specific position. And before he do the DP operation, the thematic positioning operation, he need to log in all the operation journal, like where's the current position of the vessel, and which position he needs to move the vessel to, and the weather condition, and this cannot be checked with the system. He has to go use all the materials he can reach to get this information. So there's the phone. He will need to use this phone to call the engine room. The engine room has such information, engine standards, and the weather conditions, waves, wind, how big it is, and then he has to write it down before he go back to the operation area, as I showed before, the workplace, to move the vessel to a proper position. And such information, as well as the engine standard, has to conform with the engine room. So this is what I mentioned: awareness. And as we analyze what the awareness in this situation, he need to responsible for all the information like the weather and the wind and the engine. So he's the person who need to understand such information before he do any actions. And this kind of the actions is the outside of the operational area. So if we map out the activities he has, then it's we put it into the he has, and the engine room, the engineers who respond and conform with the engine standards and the weather. So this can be mapped out as the Nightwalk, the actor Nightwalk, the person who works in the two different places. One is on the bridge and one is in the engine room with different machines. And this person who works with the DP systems and the engine room person who is control the engine. So I use these two concepts to work together, and awareness in the actor Nightwalk to help us to visualize the work practice and their activities in the Nightwalk. And this kind of fundamental basis for the marine engineers to communicate designers. And we hope this kind of the Nightwalk can show the engineers who is in the Nightwalk and who it is, and what type of support they need, and what kind of the machines they are working with. And we give the name to this awareness in the ANT, and we call this transferring technique. And we call it transferring technique because the tools or the language we use to visualize the actor Nightwalk is already there. especially for the informatics field, and we are using the user modeling language, UML. This technique is attempt to visualize the importance of cooperative work activities and their work procedures with the computer systems. And the aim is to bridge the distance between the maritime engineers and the CC designer. And I will start from the awareness, how from the individual awareness to the group awareness, in between, what is the we awareness. As I just said before, the people who stand there has to check all the information he has before he do the operation to position the vessel. So this activity we can understand is safe awareness because he aware of the safety issues like the weather condition and, for example, wave and the wind. And he also need to conform with the engine room, whether the engine, the power is okay for him to manipulate the system. And such system, as I said before, has to be conformed with the engine engineer. So they establish this one. For the first engineer, he has some activities which is outside the maritime DP system, position the vessel to the proper position, and this is the additional information he has to reach. And this has to be visualized for the engineers to incorporate such activities into the current maritime technology. And if everything is okay, and he positions the vessel to the proper position, and they have to communicate with the people who work on the platform. As you can see, the platform is higher than the vessel, and when they need to loading or lifting some containers to the platform, there's the crane, and such a crane cannot be, say, the person who walk on the bridge. So this guy has to stand up and hand over his work to another guy, just to sit beside him, and he need to assist him with that person to tell the person orally where's the crane in the left side is, and to adjust the position of the vessel. And in this case, and if we understand that is this person need to aware where to position the vessel, and another person who control the vessel to move the vessel to the proper position, they establish the kind of the way awareness, because they have the same purpose to position the vessel to the very specific position safely and less risk. So we visualized this kind of activity like this, use the UML. And the first officer and the chief officer, another person, to work together with the DP system, and they need to share some information with the person who work in the engine room, and to check whether engine standard is okay for their operation, and also need to conform the weather condition is okay. If the weather condition is not that safe for operation, they have to make some. They have to cancel their activity in some degree, and this should be integrated with the maritime technology, as well as to integrate it with such functions into the maritime operational system. And if we extend this awareness a bit to the platform, then when they look at the crane, where the crane is, and the chief officer and the first officer readjust the vessel to the proper position, they need to establish the communication between the people who work on the platform to adjust, to find the crane, and to make sure where to position the vessel under the crane. So the activity can be visualized like this. And such visualization, as we understand it, can support community, especially for design community, with the readable visualization of the actor Nightwalk. And this is not new for the designers to visualize the activity at Nightwalk, because designers have the ability to integrate the activities into the Nightwalk, as most ANT analyzes for the most work in the different field, non-maritime domain, and they can analyze how the work is connected and what is the work procedures and who is the operator in this Nightwalk and how the system works with the different operators. But without visualization, designers describe this kind of the phenomenon to the engineers maybe less efficiency. As the engineers in the maritime domain, they say it's quite difficult to understand the descriptive approach. When the people describe, especially designers describe how the people work with the machines and how they work as the network with the machines, it's difficult for them to highlight what activities can be linked from the one person to a machine or from a group of persons to an integrated environment. So it can support the design community to make the readable visualization of the Nightwalk. And for the engineers, it can use the same technique, the Nightwalk, to understand the work procedures based on the given material environment. And with that kind of the Nightwalk and the visualization, the engineers can understand what kind of the activities the human operators did with what kind of machine and what kind of material on the board, and highlight active actors in the Nightwalk, especially to identify what kind of the missing functions in the operational system and consider to make some supports for such activity. And we think this visualization, of course, challenges the structured cooperative system, as I discussed in the very beginning when we involve the human activities into the system design. Then the system design is not only for the automation purpose. It's, in some degree, it's also for the cooperation purpose. So we need to consider how they make the structure to scope this kind of the cooperation between the human and the machines. And this can enhance the mechanical computing, especially for the automation purpose, to include the social material activity, and rather than leaving them out, as the most engineering field did right now. But this kind of a technique does not design the engineering work. Says this kind of the work is kind to add is kind of the aid to the engineering design to tell the engineers how the work is done in an cooperative, in an integrated environment of machines which involve the human operators inside. And they still have the place or a role to detailing such functions when they give in the support for the activities when people use the system, and especially for those problem area and the missing functions in current system. So this language we use is already exists there. It's not a new language. So it's easier for both sides to communicate. So they can understand each other with this common language in some degree. So this is our work, and we still aiming to verify how this kind of the language can be improved in the future. Yeah, thank you.
Thank you. Thanks very much for that. Very interesting question.
Yeah, I'm wondering, have the people working at those platforms, have they approached you in the first place and asked you that somehow their work process has to be optimized, or are they actually quite okay with the way they work at the moment? because I can imagine that in such an industrial context, after some years, they have their routine and everything, so they might even not see the necessity to have anything improved, or is it really the case that they say, yes, please, we want to get rid of, for example, all that paperwork, so can you help us develop something more automatic?
Yeah, this is not they are waiting to me to make some improvement, because every year, especially in Norway, in the maritime industry, they have the training purpose from the company. They send their employees to the institution to test the institutions, simulators, as well as to get some feedback for their current work and to say, as the training purpose. So we have some feedback from the marine engineers and the marine operators and say, and they provide some in their understanding what is the risks and what is the unsafe operations they face, and they would like to get some benefits from the institute to improve this area. And this is continuously recent years. And they wish to have some new bridge or new system, but it's quite difficult to redesign the whole system like the big machines like this. So, yeah.
Could I ask you then?
Yeah.
The pictures you showed, it was a very calm, pleasant day when you collected your data.
Yeah.
What do you think would happen if you'd have collected your data, and do you think anything would have changed in terms of how you constructed this? If you had collected your data in a raging sea when people weren't being calm and saying, oh yes, I'm doing this and I'm doing that, because one anticipates that the communication between people then becomes a little bit more exciting.
Yeah, and the data I claim that is I showed here is just for the very climate date. And when the weather condition is quite extremely bad, so they have the standard, for example, for the waves. If the waves are higher than 4 meters and the wind is higher than 3 meters per second, they have the choice. They can stop their walk and wait. And sometimes they have the schedule, which is pushed by the oil company or the shipping company, because they have the economics situations when they need to go back to the quay and position a vessel there, or when the next group of crew need to come back to the vessel to walk. So sometimes they put themselves into the risk consideration, the situation. And in that case, the communication is not that claim. In that communication between the vessel and the platform is extremely, how can I say that? It's chaos. Yeah.
So how would your proposed method address this issue of cooperation suddenly becomes control and conflict? Because that's, I think, is what you're talking about.
Yeah. One thing is that I observe them and to listen to them how they communicate. Sometimes it's quite difficult to communicate. Then because the communication channel is not point to point, it's kind of the broadcast. So you can hear the communication in this loop from the platform to the vessel, or from the vessel to the platform. Sometimes the misordered, and then I interrupt in later on, like the interview with the crew members or call to the platform to discuss this issue afterwards. Yeah.
Okay, well, I mean, it's always
There's the one more.
It's on. Okay. Yeah, I was just wondering, since what you're describing here is sort of a complex social material system, how did you find the responsibilities of the operator on the platform? And if I understand right, the responsibility for the safety of the vessel is always at the commander of the vessel. Who makes the final decisions, and is that perfectly clear within the system, or is there room for improvement in that part as well?
And for the mooring operations like this, everybody has the decision of their own work. Not there's the commander, as I said, the chief operator. He plays the role as the call walker for the first operator. So there's even though there's some hierarchy of their titles, but the decision making just a bit depends on their own situation.
Okay.
Yeah.
Thank you.
So you are also saying, because when you showed that big graph with how they are all interconnected, it almost seemed like, yes, the humans, the people are pretty much only also just parts of a big machinery, and if you do it correctly, then you could just automatically deduce whatever is to be done depending on the weather and on the engine.
Yeah.
But I wonder, is there still some human intuition or some decision that has to be made with a responsibility depending on the weather and the engine conditions, or is it something pretty much deterministic that also an algorithm could perform at some point?
Yeah, they have to make some decisions, especially for response for other people's safety or less risks. Like I showed in one picture, like this in the middle. The crew members work on the deck. This person's, their operation is kind of to assist the people who work on the bridge, control room, and the people who work on the platform. They play the role as a mediator to forward the message from the platform or to give some guidance to the platform and the bridge, lifting the stuff or putting the stuff to the very specific position of the vessel. In order to balance the vessel, sometimes the container is quite heavy. So due to the ship is sometimes quite huge, so when they putting down the container or they lifting the containers, this kind of people's life is extremely dangerous. So they need to use their communication to tell the people who work on the bridge where and how high the first try to lifting the container and moving it to the left or the right side, just a bit, just try it. Then regarding to the wind, then they decide to how to move this one safely with the very specific roles up to the platform. Of course, the platform guy who control the crane to take it up, they also communicate with the person who standing on the deck. And when he already put it up, they need to tell the guys who a very specific position of the deck to hide themselves.
Okay, thank you. Well, it's always important that we have papers which investigate how you can improve design and understanding upfront, particularly in safety critical systems like this. So please join me in thanking Yushan for a really interesting paper. Thank you.
Thank you.